Okay, so we're going to go ahead and solve another fun pulley problem. So the figure below represents a pulley system where masses little m and big M are connected by a rope over a massless and frictionless pulley. Mass m is greater than mass m. Note, your final answer should only include variables. Find the acceleration of the system. Oh, fun. Cool. So just imagine a good old pulley system. So let's think about first what direction this whole thing is going to move. Okay, so mass big M is bigger than mass little m. Oh, that's kind of appropriate. So the system's going to move that way. Cool. So first thing we always do is we go ahead and draw a free body diagram. So I know that there is gravity acting on this. So gravity, which will be mg, so it's little m times acceleration due to gravity. We have tension right here. Okay, then the other thing, we have tension right here. And then we have Fg, which in this case is going to be big M, little g. Cool. So if it is a massless pulley, then we know that tension is the same throughout. Because imagine, just think of this as like it's one whole rope right here. This tension will approximate to be the same. Not true in real life because pulleys actually have mass, but it's pretty approximate for what it would act like in real life. Cool. So we're going to call the direction the system moves as a positive direction for our coordinate system. So we're going to call this direction the positive direction. So any forces pointing in this direction, which I have indicated, are considered the positive direction. So let's go ahead and look at each force. So Fg equals big mg. That is pointing in the direction it moves, so that's positive. This tension is pointing opposite direction, so that's negative. Okay. This tension right here, it's moving upwards this direction, so that's positive. And then Fg is pointing the opposite direction for little mg, so that's negative. And keep in mind the direction of the rope, we define that to be the x direction in this case. So any forces along the direction of the rope, which is everything in this case, is just all the x direction. Cool. So let's go ahead and now set up Fnet for each object. So for big M, okay, and I encourage you to do this yourself first and then check back into the video. So Fnet for big M, we have Fg and T. So Fg is positive, tension is going back the opposite way. Okay, so Fnet is Ma, so it's big M times A is equal to big Mg minus T. Cool. Okay, can't really solve anything there, simplify that. So let's go to the other one, little m. So we have Fnet equals, and again, try it yourself first and then check back in. Okay, so we have tension is going upwards positive, gravity is going the opposite direction. Okay, so Fnet is little m now times acceleration equals tension minus little mg. Cool. And we know the system is all connected, so the acceleration of the system is going to be the same. So now let's look at it. We have two unknowns and two equations. We don't know little a, we don't know t, and the m's and g acceleration due to gravity are allowed in our final answer. Cool. So we could like solve for t here or solve for t in the other one and plug them into each other and solve. I love, though, using elimination. It's just my favorite. So let's go ahead and try elimination. So we have ma equals mg minus t. And then here is little ma equals t minus mg. We can add these two puppies together. So this is big ma plus little ma. And keep in mind these are two different m's. So it's not 2ma. It's big ma plus little ma equals, okay, mg and mg. Those are two different mg's. So we can't cancel those. So it's big mg minus little mg. These tensions are the same though, so we can say toodaloo to those. Cool. So we're trying to solve for acceleration. So think about how can we get acceleration by itself? Looks like we need to do a little good old factoring. So let's pull out an a from each term on the left. So it's big M plus little m equals, if you wanted to factor out a g on the right hand side, you could do that, but I'm just going to leave it, mg minus little mg. So then we can divide both sides by big M plus little m, big M plus m, and then acceleration is mg minus little mg over m plus m. Cool. And that looks like a pretty darn gnarly answer, but that is the acceleration of this system.